All right, finishing up chapter 7, section 1, roots and radical expressions. All right, so we see our first example here. It says x to the power of 4 equals 0.0001. All right, notice that this is an even exponent. So to get rid of this exponent, we're going to take the fourth root of x to the power of 4. If you do that on the left side, you have to also do that on the right side. Now, even, you need that plus minus. So I need the fourth root of 0.0001. You can get that on your calculator. I'm going to turn my calculator on. Remember, on the graphing calculator, it's in the math menu. Yeah, if you don't have a graphing calculator, then you're looking for this root right here, the x root. All right, but the only thing is, whether I use the graphing calculator or the regular calculator, I have to type in the root first. I have to type in the 4, and then I'm going to pick up that function. Okay, this is telling me the x root, and this in the front is telling me that that index is 4. And then I'm just typing 0.0001, hit equals, and I see it equals 0.1. All right, so x is equal to positive, negative, 0.1. Giving my two answers separately, negative, 0.1, and positive, 0.1. Okay, now here in the next example, we have x cubed equals 27 divided by 64. So remember, when you solve equations, you always do inverse operations. What's the inverse of raising to the power of 3? Well, the inverse of raising to the power of 3 would be to take the cube root. And if you do that on the left side, you also have to do it on the right side. So the cube root of x cubed is x. I do not use plus or minus here, right? Because odd roots only have one answer. It's the even ones that have 2. All right, I'm going to bust this apart. This is really the cube root of 27 over the cube root of 64. Nothing new. We've used the quotient rule before. Cube root of 27 is 3. Cube root of 64 is 4. So I see here that x equals 3/4. So if you have questions, please reach out. Let me know so I can help you. All right, this problem right here says the volume of a cylinder, the formula for volume of a cylinder is that formula right there. And here it says, if V, the volume, is 50 inches cubed, find the radius to the nearest hundredth. Well, let's look at the formula. V is volume. Pi is not a variable. It's an irrational number. Pi is pi. And r is my radius. All right, I have to solve this thing for r. Well, I'm going to substitute what I know into my formula. V, the volume, is 50. So I'm going to replace this v with 50 and end up with the equation 50 equals 4/3 times pi times r cubed. Folks, we can break this down. And we could set it up so that this is easier for us to have less steps. First, what you have to realize is that pi is really pi over 1. And so I'm going to rewrite this as 50 equals 4 pi over 3, right? Because 4 times pi is 4 pi, and 3 times 1 is 3, times r cubed. This is the preferred method. Now, to get the r cubed by itself, because remember we are solving for r, solve for r to the nearest hundredth. To get the r cubed by itself, I'm going to multiply by the reciprocal of this on both sides. Right? Whatever you do to one side, you do to the other. I want to multiply by 3 over 4 pi on the left and on the right. Okay, because I want these 3's to divide out, and I want these 4's to divide out, and the pi's. Folks, in the top here, I have 3 times 4 times pi is 12 pi. 4 pi times 3 is 12 pi. This is 12 pi over 12 pi. That equals 1. So I get 1r cubed equals, now this is 50 over 1. All right, you could do 3 times 50. What do you got? 150 divided by 4 pi equals r cubed. Now, what do we do to get rid of the cubing? I'm going to switch sides so it looks nicer. R cubed equals 150 divided by 4 pi. All right. How do I get rid of the cube? I take the cube root. So r equals, I do not need plus or minus. Odd roots only have one answer. So this is the cube root, 150 over 4 pi. Now here's where students are going to mess this up. They're not going to put 4 pi in parentheses. And I'm going to show it to you both ways. You are taking the cube root of 150 divided by this product. So you need parentheses. And in fact, if you're going to put this in the calculator as one thing, then you need parentheses here. So those of you that don't like to use parentheses, this is going to be a little bit of trouble for you, especially if you're thinking you're going to put this in the calculator at one time. So I'm going to type in the cube root. You should have the cube root on your graphing calculator. You go into math menu and there's cube root. Otherwise, you're going to have to type the 3n and pick up this x root. All right, that's cube root. Cube root of what? Parenthesis for the fraction. 150 divided by parenthesis for the product. 4, and I'm going to use the pi button. Okay, find the pi button on your calculator. I don't know where it is. Close the product. Now close the fraction. It's really important for you to use the parentheses so the calculator knows what you mean. I want the cube root of this quotient. I want the cube root, the quotient, I want it to divide 150 by 4 times pi. Hit enter. You are rounding to the nearest hundredth. The number 100 has 2 zeros, therefore we are rounding to the second place. So r is approximately equal to, you got to use the wavy equal to sign because we're rounding, approximately equal to 2.29 inches. You need units. Okay, now I want you to actually try this on the calculator as you're watching this video lesson. Okay, I'm going to show you what happens if you don't put the parentheses there. So I get the cube root. Oops. There's cube root. Cube root of 150 divided by 4 pi. There it is. No parentheses. That is not the same answer. All right, let's try one more thing. Cube root of parentheses for the fraction. 150 divided by 4 pi. Close the fraction. It's still not the same answer, and it's different than this one. Okay, the first answer is the correct answer. You're telling the calculator, take 150 divided by the product of 4 times pi. Once you find that, then take the cube root of that. Okay, here this is saying take the cube root of 150 and divide it by 4 pi. Here this is saying take the cube root of 150 divided by 4 and then multiply it with pi. Okay, that's why you're getting 3 different answers here, because of the grouping symbols on the calculator. So do this, please. Group the fraction and group the product in the denominator. Otherwise, again, you're going to get the wrong answer. Okay? All right. Try the next one on your own. Push the pause button and see if you can get that one correct to the correct amount of decimal places. Okay, hopefully you paused the video and went through the process. You replace the v with 10. 10 equals 4/3 pi times r cubed. Rewrite the 4/3 pi as 4 pi over 3. Multiply by the reciprocal of this on both sides. Multiply, I get 30 over 4 pi. Take the cube root. Group the fraction, group the product, and type into the calculator. Okay, notice my way I'm typing in the calculator. I got cube root. These parentheses are grouping the fraction, and then I'm grouping my product right there. Okay, if you have questions on how to use your calculator or on this process, please ask. Don't forget, you got to get used to that grouping on the calculator. Okay, one more problem to do in this section, an application problem. And it goes something like this. A cheese manufacturer wants to ship cheese balls that weigh from 10 to 11 ounces in cartons that will have 3 layers of cheese balls by 4 cheese balls. Cheese ball is kind of like, sometimes at the holiday time, you make a cheese ball out of cream cheese and shredded cheese, and, you take some kind of a, like a spread tool, because the cheese ball is kind of like a spread, and you spread it on crackers, or, anything that you want to put the cheese on. It's a cheese ball. So it's saying a cheese manufacturer wants to ship these that weigh from 10 to 11 ounces. Oh, so the weight is going to be between 10 and 11 ounces. So it's going to be greater than 10, but less than 11, and it could be equal to those. So there's my inequality that represents this situation. It's going to have 3 layers of 3 by 4. Okay, so 3 by 4 is going to be 1, 2, 3 by 4. And then, of course, we're going to have 3 layers of this. So it's going to be like a bottom layer, then a middle layer, and then an upper layer. All right. The weight of a cheese ball is related to its diameter by the formula W equals D cubed over 5. Where D is the diameter in inches. Remember, you always have to include units if the units are known. In inches, and W is the weight in ounces. Well, folks, if W equals this, then this W also equals that. So I'm going to replace it with D cubed over 5. What size cartons should be used? Assume whole inch dimensions. Folks, I need to find the diameter. Okay, the diameter of one of these cheese balls. So, if this was one of them, I need to know what is the length from there to there. And then I got to figure out, well, from here to here, and then from here to here, and then from here to here, and then from here to here. Because we're being asked what size cartons should be used. Okay, so I need a length, a width, and a height of a carton that would fit these nicely into for shipping purposes. All right, well, the first thing we got to do is to solve this thing for D. You need to know what D is. Guess what? D cubed over 5. I'm going to multiply this by 5, and this by 5, and this by 5 to get rid of the 5 in the denominator. Okay, when I do that, 5 times 10 is 50. This is 5 over 1, so the 5's divide out. That's why we multiply by 5. D cubed less than or equal to 11 times 5 is 55. All right, well, this is a compound inequality. We've worked with these before. Whatever we do in the middle, we do to the left and the right. I just showed you right here. Whatever we do in the middle, we do to the left side and the right side. Now I want to get rid of the cubing. It makes sense to take the cube root. Cube root of 50 less than or equal to D less than or equal to the cube root of 55. It says assume whole inches, so we're going to round. But right now, let's just figure out what the cube root of 50 is. Cube root of 50. Looking like about 3.68. Cube root of 55. Uh, 3.80. All right, well, it's somewhere in between here for each one of these. So now I'm going to write out the length of a row with 3 cheese balls, so I'm talking about this, is 3 times what? Times what? I can't use this value here. You know, I need a box that's going to be big enough, or a carton that's going to be big enough to fit the largest. So I have to use this. Okay, because if it's smaller, it will still fit in the box. But if it's larger, if I use this, and the cheese ball ends up having a diameter of this, I'm in trouble. I'm going to have squished up cheese balls. I don't want that. So I have to use the larger. Okay, so this is the length of a row with 3 cheese balls. 3 times 3.8 is about 11.4 inches. All right, now I'm going to look for the length of a row with 4 cheese balls. All right, so that's now going to be 4 times 3.80, which is about 15.2 inches. Now, I have to figure out the height. The height of the carton. Remember, we said we were shipping or packing this in a carton 3 layers of 4x3 or 3x4. So that also is a 3 times 3.80, which is about the same as above, 11.4 inches. And now my final answer. Okay, so we're going to write the dimensions of the carton. And this is my answer. 11.4. Folks, I can't round down. Because if I need exactly 11.4, an 11-inch carton's not going to fit everything. So I have to go up to the next whole inch dimension. So for this piece, I need a 12-inch by, you tell me, 16-inch. I'm hoping that's what you said. By 12-inch. Okay, now the height. This would be length times width times height, right? Because the height was 3 layers. So again, the dimensions of the carton has got to be a 12 by 16 by 12. Length times width times height. Okay, so let's see what you can do with problems like this, application problems, and using our method of solving by taking the cube root. Okay, if you have any questions, please reach out and I'll be more than happy to help you. Have a great day.